are on section 3 of chapter 10, still just looking at triangles. We're going to be looking at special triangles and reciprocal ratios. So these are triangles that if you have certain angles or a certain ratio of the sides, you always know what the other side is going to be or what the other angle is going to be. You don't even have to worry about using the Pythagorean theorem or using sine or any of that stuff. You just look at the ratio and you say, oh, I know this is one of those special triangles, so I know what my missing numbers are. Your homework is 11 through 26 at the end of the section. So, two of the most common, basically, types of right triangles are 30, 60, 90 triangles and 45, 45, 90 triangles. Those are just angles that you're going to see a lot. And if you look on your book on page 404, you will look at you will see the ratios of those triangles. So, if you have that's 90, that's 30, and that's 60, then it's going to be a 1, 2, but then square root of 3 triangle. So it's always going to be that ratio. Is it always going to be 1, 2, square root of 3? No, but maybe you will have, for example, 3, sorry, not 3, let's do square root of 6, 2, then you know that this one's going to be 4 because it's just double all those numbers. Or if you have a triangle that's a 3 here and a 6 here, well, you know you're tripling them, so you know that's going to be square root of 9. Okay, so, 3 square root of 3. So you just know that if you have those ratios, that's going to be the answer. Or if you don't have but one of the sides, maybe you have this side as a 10, but you have that angle's a 30 and that angle's a 90, you still know it's a 30, 60, 90 triangle, so you multiply everything times 10. So you get 10, 20, and then 10 square root of 3. So it's just the same ratios if you ever see that triangle. Now the 45, 45, 90 is a tiny bit easier. Okay? Alright, square root of 2. Keep forgetting the square roots. So in that case, you're always going to have a ratio where these two sides are going to be the same, which makes sense because the angles are the same, right? And then that's going to be square root of 2. Again, it's not always going to be 1 and 1, but say you have 7 and 7. Well, that's 7 square root of 2. You have 13. 13 square root of 2. So it's just the ratios. And again, you can still use the sine and the tangent and the cosine or Pythagorean theorem, but if you're trying to get through a bunch of triangles fast, you can always look for these and then you'll be able to just keep those ratios and solve your triangles a lot faster. Okay, so there's the 30, 60, 90, which is always 1, 2 square root of 3, or some multiple thereof. And then there's the 45, 45, 90 triangle, which is always 1, 1 square root of 2, or again, some multiple thereof. Now, if you go to the bottom of page, 404, it shows you that if you use the Pythagorean theorem, or if you use sine and cosine, these are the numbers you would get. So it's just kind of proof that they're telling you the truth, that they didn't just make it up. You are welcome to look at that, but mostly you just want to memorize this, okay? So let's look at example 1. They want you to solve triangle EFG. Now remember that they have to tell you what the angles are. It doesn't matter what it looks like. If you're like, oh yeah, that looks like a 45, 45, 90. It doesn't matter. You have to make sure that they're labeled as a certain type of triangle, okay? And they're telling us that's a right triangle. Then they're telling us this is 30, this is 60. Now, unfortunately, that's not enough. You have to know at least one side in order to be able to figure out all these values. And sure enough, they actually give us 2 of the sides. They give us 9, they give us 8. Okay? Now, remember, solving a triangle means that you're going to fill in every single angle and every single side. In this case, what are we missing? We have angle, 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 we have side, side. So we're just missing one side. Now, this is a 30, 60, 90. So we know the ratio, right? The side opposite 60 is going to be square root of 3. That's the one we don't have. Let's make sure all the other ones add up, right? The one opposite 90 is going to be 2. So what's half of that? What's that divided by 2 is 4.5. And then the side opposite 30 says it's going to be 1. So in this case, it's not following, let me make sure I wrote all the numbers down right. No, okay, I was going to say it's not following the numbers properly. That is not a 9, apparently that is a G. So we only have to look at this side. So we have to look at this number, which is opposite 30. You can draw these triangles when you're doing your homework, when you're doing the test. Draw yourself a 30, 60, 90 triangle so you can go back and look at it instead of having to try to do it all in your head. Okay, so I have the side opposite 30, which is my side that's normally 1. So that's going to be my ratio, 1 to 8. That's pretty easy. That just means I got to multiply those guys by 8 and I'll have my answer. So G, and this is E, I think. G is opposite my right angle, which means it's my hypotenuse, and that's 2. So if I have to multiply it by 8, what's that going to be? 16. Pretty easy, right? E is my side that's opposite my 60-degree angle, which is my square root of 3. I got to multiply it by 8. It's just 8 square root of 3. And let's check. That should be what the book got. They got... well, they have it in numbers, which is 13.86 is E. Let's just assume that that's what that is. You guys can check that on your calculator. And for G, they got 16, which is what we got. So it was pretty easy, but notice they actually plugged in the sign and all that into the calculator and got those numbers. So if for some reason you totally forget these triangles, just do it the long way. Just plug sines or cosines or tangents or do Pythagorean theorem, whatever you need to do. But it's a lot faster if you just have the triangle and do the ratios. Now, in example 2, they want you to find the sine and the cosine. Again, remember, you can plug angles into tables, or you can remember SOHCAHTOA, which is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. I'm going to leave these guys as a reference, but I'm going to erase this bottom triangle so I can draw out the ones from example 2. I'm going to go ahead and draw both of them, okay? There's an ABC triangle. Sorry, those are terrible triangles. That's 90, 60, 30. Let's see what numbers they give us. That's the square root of 3, 2, 1, so that's pretty easy. Oh, it's actually these exact triangles, but we'll draw them again just in case. 45, 45, so that's square root of 2, 1, 1. They want to know the sine of 60, let's write that down, and they want to know the cosine of 45. So again, I don't have my calculator, but I can get you started on the numbers. So sine is opposite over hypotenuse. Here is our 60-degree angle. Opposite is square root of 3. Hypotenuse is 2. So you can plug into your calculator square root of 3 over 2 and you'll get some number. They don't even do it. Cosine of 45. What's cosine? Adjacent over hypotenuse. There's our 45-degree angle. Adjacent is 1. Hypotenuse is square root of 2. But you guys have taken algebra, so you know that we have to do that because we do not like square roots at the bottom. So we get square root of 2 over 2, which is what the book gets. They actually don't take it any further than that. Okay, so again, you could plug it into your calculator, but you just remember these triangles and it just makes it go a little bit faster, okay? Now, we have 3 new terms, which you should also be able to plug all these guys into your calculator. You have cosecant, secant, and cotangent, and those are just the inverses. Okay, so the cosecant is the reciprocal of the sine, the secant is the reciprocal of the cosine, and then the cotangent is the reciprocal of the tangent. What does that mean? What's the reciprocal? 1 over the sine. So even if you can't plug it into your calculator, you can plug sine into your calculator, right? And then you can just do 1 over the sine. And then secant is 1 over the cosine, and cotangent, that's an easy one, 1 over the tangent. Now you gotta remember when you're writing secant and cosecant, they do have different letters. Cosecant is C and cosine is COS, but they get really similar. So you're probably better off just writing cosecant and cosine, because you can easily get confused, so it's better to just write it out. okay? So again, you can find them exactly the same as you can find them before. You have to have the sides, or you can have the angles and plug them into your table in the back, or plug them into your calculator. So in example 3, if you have two sides and an angle, or you have one angle and a side, as long as you have two values basically, just like that's what you need to find sines and cosines, that's what you need to find the cosecant and the secant. Now in example 3, they want you to find all 6 trigonometric ratios, right? So you have to find sine, cosine, tangent, secant, and cosecant. So I'm going to erase these guys, and I'm going to draw out that triangle, okay? And it's, let's see, example 3. And do they give us any angles? They don't give us any angles, okay? So we're going to have to find the secant, the cosecant, the cotangent, all the sine, cosine. We have to find all of that by doing the ratios of the lengths. However, we don't have all the lengths. So the first thing you have to do is use the Pythagorean theorem to find the third length. So we're going to do 3 squared plus 5 squared equals 9 plus 25, which is 34, right? So this is square root of 34. Let's check what the book got. Yep. Now we have all the values, so we should be able to find sine, cosine, tangent, cosecant, secant, and cotangent. Let's start with these guys because we need these guys to find these guys, right? So let's erase these numbers from the previous problem. And sine, and you have to find them. Are they doing them for both angles? Let's see. Blah, 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 blah. They're finding, yep, so they're going to find all the values. Oh no, they're just finding them for angle A, which in this case is this angle right here. So that's the only one you have to find it for, okay? So what is sine? Opposite over hypotenuse. Opposite is 3. Hypotenuse is square root of 34, but we don't leave that at the bottom, which equals 3 square root of 34 over 34. Hopefully the book got a numerical value for that. No, they left it at that, okay? Let's go to cosine. What's cosine? Adjacent over hypotenuse. Okay, so what is adjacent to that? 5. We get 5 over square root of 34. Again, we don't want to leave it at the bottom. So we're going to get 5 square root of 34 over 34. Last one we have left is tangent. Opposite over adjacent. Opposite is 3, adjacent is 5. Okay, so there's all those ratios. Now we have to find cosecant, secant, and cotangent. Well, it's the inverse. We have fractions here, so you could say, oh, okay, I got to figure out what 3 square root of 34 over 34 is, and then do 1 divided by that. You could also just flip it. Remember, the inverse is just flipping the fraction. So the cosecant is just going to be that flipped over, which is going to be except remember we don't like the square root at the bottom, so we got to multiply it again. This is 34 square root of 34 over 3 times 34. Those cross out. So it's square root of 34 over 3, which tells me, let's just use this one and flip that over, right? So now we get to secant. And we learned from the cosecant that we're just going to flip over the term before we made it rational. So before we rationalize the denominator. So we're just going to flip this guy, and we're going to get square root of 34 over 5. Last one is cotangent. We're just going to flip that guy. So you get 5 over 3. And hopefully that's what the book got. Yes. Okay, so piece of cake. Again, your homework is going to be problems 11 through 26. In problems 11 through 18, you're just going to use your calculator to find it. And then in 19 through 26, you have triangles that you have to solve. Sometimes you get angles, sometimes you get